Welcome to the first course on reliable distributed algorithms. We will start the first lecture with a gentle introduction to distributed systems, including core problems and distributed system models. After this introduction, we will give in lecture 2 formal models of asynchronous distributed systems. In particular, we will give an introduction to input-output automata. This is a formalism used to describe interacting systems formally. It defines precisely what is a distributed algorithm, what's an execution of a distributed system, how to define and specify a problem, and how to prove that an algorithm solves the problem. This lecture is formal, but it is optional. If you're not used to mathematical treatment of algorithm, I recommend that you cover the review material and browse the material quickly and continue with the next topic. One unit is, however, important. It is the unit on causality and logical time. We try to make the rest of the course independent of this material. You will also get introduced to the software used for programming assignments in this course. It is an event-driven component middleware called Compex, and it is hosted in the programming language Scala. This ends the first week. In the second week, we will have 2 lectures. Lecture 3 covers the event-driven model that is used to define algorithm in the course. It covers the specification of problems or distributed services using safety and liveness properties. Then we will define our various distributed system models and the failure modes of processes and channels. Lecture 4 is devoted to failure detectors and the issue of reducibility and equivalence of various distributed abstractions or problems. In the third week, lecture 5 and 6 will cover reliable broadcast abstractions, including reliable broadcast and causal order broadcast. In the fourth week, in lecture 7, we'll turn our attention to distributed shared memory. We'll define various consistency model of shared memory or shared stores, and the algorithm for implementing fault-tolerance distributed shared memory. In the fifth week, we will end the first part of the course with discussing single-value consensus, discuss impossibility of consensus in asynchronous systems, and go through in detail the Paxos algorithm, including its correctness proofs. Throughout the course, we will have programming assignments on the various algorithms that we discuss in the course. We will also have weekly graded quizzes. There is no final exam in this course. To pass the course with full points, you need to do the graded quizzes and deliver the programming assignments. We will be available in the discussion forum to assist you throughout the course.